In this video, we're going to talk about applying the distributive property. First, let's review what the distributive property says. Let A, B, and C be real numbers. In words, the product of A and the quantity of B plus C in algebra written as A times the quantity of B plus C equals A times B plus A times C. An example with numbers. 3 times the quantity of 4 plus 2 equals 3 times 4 plus 3 times 2. The quantity of B plus C times A equals B times A plus C times A. The quantity of 3 plus 5 times 2 equals 3 times 2 plus 5 times 2. We could also think about this in terms of subtraction. The product of A and B, the quantity of B minus C, in algebra can be written as A times the quantity of B minus C equals AB, or A times B minus A times C. 5 times the quantity of 6 minus 4 equals 5 times 6 minus 5 times 4. The quantity of B minus C times A equals B times A minus C times A. The quantity of, in numbers, we could say the quantity of 8 minus 6 times 4 equals 8 times 4 minus 6 times 4. Some other vocabulary. Equivalent expressions. Two expressions that have the same value for all values of a variable. And then some general terms with algebra. So we have terms. They're split by operators, such as addition or subtractions. If we look at our variables are letters, the numbers in front of the variables are coefficients, and numbers that stand out by themselves are constants. Example 1. Use the distributive property to write an equivalent expression. So we have 4 times the quantity of y plus 3. So we're going to use a area model and by just using the traditional distributive property. So a lot of times when we use the distributive property, the common mistake would be students would just do 4 times y plus 3. That's not what you want to do. You have to distribute all the way through, multiply to everything. So right away, if we say y equals 2, so we know area equals length times width. So if we use our y equals 2, we do 4 times 2 plus 3. That should be, that gives me 11. But if we look at it as a rectangle, if we plug 2 in for y, that means we're doing 4 times 5, which my area should be 20. So that's why we have to distribute all the way through. So let's correct our mistake. So we have 4 times y plus 12. Now if we plug in 2, 4 times 2 plus 12, that gives me 20. So I did do the correct work. So make sure when you distribute, you do have to distribute all the way through. Okay, now we have n times the quantity of n minus 3. Sorry, n minus 9. So we can think about this as dividing to a rectangle, or we could think about it also as the traditional distributive method. Let's look at the rectangle first. So we have n times n, that's going to be n squared. N times negative 9 is going to be minus 9n. So we have n parentheses n minus 9, distribute. N minus n would be n squared minus n times 9 be 9n. Now if we plug in a number like say n is 1, we can double check our work. 1 minus 9 would be 8 or negative 8, and this would be 1, so 1 times negative 8, so my area should be negative 8. Let's just make sure we did the work right. 1 squared minus 9 times 1. 1 squared is 1. 1 minus 9, we get negative 8. So we did do the correct distribution property and did our work correctly. Example 2. Use the distributive property to write an equivalent expression. So we can divide this into a rectangle. We'll look at it as a rectangular method and using the traditional distributive property. So negative 2 times x would be negative 2x, and negative 2 times 7 would be negative 14. Traditional distributive property, negative 2x plus 7. Negative 2 times x will be negative 2x, and negative 2 times positive 7 will be negative 14. So we got the same thing when we worked it out using our rectangular method and by distributing. B. The quantity of 5 minus y times negative 3y. So if we distribute 5 times negative 3 would be negative 15y. And negative y times negative 3y should be positive 3y squared. So let's see that worked out with using the traditional distributive method. Negative 3 times 5 would be negative 15y. Negative 3 times negative y will be positive 3y squared. And we got the same answer. And then last, we have negative 2x minus 11 in parentheses. So even though it doesn't say it, we can assume this is negative 1. So negative 1 times quantity of 2x minus 11. So negative 1 times negative 2x would be negative 2x, and negative 1 times negative 11 would be positive 11. Let's double check our work with the distributive property. Negative 1 times 2x would be negative 2x. Negative 1 times negative 11 will be positive 11. And we got the same answer twice. And we are done with our distributive property for this example. 3. Identify parts of an expression. Identify the terms, like terms, coefficients, and constant terms of the expression 3x minus 4 minus x minus 2. So wherever we see a addition or subtraction sign are our terms. So we have 3x minus 4 minus 6x and negative 2. These are all my terms. Now my like terms are the ones that have that are alike. So they have the same variable, or they're both constant. So my like terms would be 3x and negative 6x. Also negative 4 and negative 2. My coefficients are the numbers in front of the variables. So my variable terms. So if we look at the 3x term, my first coefficient would be 3. My next coefficient would be negative 6. And my constant terms, they're just the numbers that don't have a variable attached to it. So we look at the expression, we have negative 4 and negative 2. Neither one of these, the negative 4 and the negative 2, have a variable attached to it. Example 4. Simplify the expression 4 times the quantity of n plus 9 minus 3 times the quantity of 2 plus n. So let's treat this as two distributive problem and then simplify it. So we have 4 parentheses n plus 9. If I distribute that, that would be 4 times n, which would be 4n, and 4 times 9, which would be positive 36. Now we have negative 3 times the quantity of 2 plus n. Negative 3 times 2 would be negative 6. Negative 3 times n would be negative 3n. Now we're going to combine our like terms. So we have 4n and minus 3n. 4n minus 3n would be just 1n or n. 36 minus negative 6 will be positive 30, and we've simplified this expression as far as we can go to n plus 30, and we are done simplifying this expression. Example 5. Solve a multi-step problem. This one's about exercising. Your daily workout plan involves a total of 50 minutes of running and swimming. You burn 15 calories per minute when running and 9 calories per minute when swimming. Let R be the number of minutes that you run. Find the number of calories you burn in a 50-minute workout if you run for 20 minutes. So to start, let's say C is the amount of calories burned. So you burn 15 calories per minute when running, 9 calories per minute when swimming. Your daily workout routine involves 50 minutes of running and swimming. And we know R is the number of minutes you run. So R equals running. So let's write our expression. So C equals, we burn 15 calories per minute when running. So that'd be 15 R plus, we burn 9 calories per minute when swimming. So that'll be 9 parentheses. Now we know we have a total of 50 minutes, so we say 50 minus R. 50 minus R, since we know that we run R minutes, this is our swimming. So now what we want to do is we want to simplify this mess. So 9 times 50 will be positive 450. 9 times negative R will be negative 9R. Bring down our plus 15R. So 15R minus 9R will be 6R plus 450. Now we know that find the number of calories you burn in a workout if you run for 20 minutes. So we need to plug in our 20 now. So it's going to be 6 parentheses 20 plus 450. 6 times 20 is 120 plus 450. So 120 plus 450 will give me 570 calories that we burned. And we are done solving this problem.